everyone, this is Michael, a data communication engineer from the Huawei Technologies. Today I want to give you a brief introduction to the stacking functions of the Huawei S-series switches. Now let's get started with the information sharing. A traditional and typical enterprise network uses a layered network infrastructure with an access layer, an aggregation layer, and a core layer. Different functions and features are deployed at each of these layers. The aggregation and core layers usually use dual-node style to prevent a single point of failure and ensure the high availability of network services. As an increasing range of services are deployed, shortcomings of this form of networking emerge. First, although the redundant design at the aggregation and core layers improve network high availability and reliability, it also increases network complexity and makes the network expansion complicated. Second, the redundant structure causes loops in the tree structure, and the ring network becomes larger as the enterprise expands. To eliminate loops, the network must run loop prevention protocols such as MSTP, and meanwhile, the network runs VRRP or other redundant protocols to support backup between network nodes. These protocols make network deployment more complex. To address these problems, Huawei S-series switches have stacking capabilities. Stacking function virtualizes multiple switches into a single logical device to simplify the network structure and facilitate network management. In addition, the member switches back up each other to improve network reliability and high availability. Now, let's take a look at some benefits of stacking functions. First, stacking virtualizes multiple switches into a single logical device. This turns a complex network into a simple, loop-free tree network, so the network does not need the MSTP or VRP protocol anymore. Second, member switches in a stack system back up each other. When you need to replace faulty member switches in a stack system or increase stack capability, you just connect and add new switches to the stack while the power is still on. This minimizes the negative impact of device replacement on the network. Third, stacking makes network expansion more flexible and extensible. You can increase ports or expand the processing capability in a stack system by simply adding new switches to the stack system. This addition of these switches will cause very little change in the network topology. Finally, switches in a stack system can be managed as a single device. This tremendously reduces the workload associated with the network management and maintenance. Now, let's take a look at some basic concepts about the stacking function. Before using a stack function, we need to understand its concepts and the mechanisms. In a stack system, the member switches compare their running status, priorities, and MAC address to elect a master switch. The master switch manages the entire stack system, and the other switches work as slave switches. After the master switch is elected, a standby switch is selected among the slave switches using the same rules. If the master switch fails, the standby switch will take over the role of the master switch. In a stack system formed by chassis switches, you can use the CSS master force command to manually specify the master switch. A stack system uses the IP address and MAC address of the master switch elected when the stack is initially set up. In a stack formed by case-shaped switches, WLAN 4093 is the reserved WLAN by default. The reserved WLAN is used for exchange of stack protocol packets between member switches and cannot be used as service WLAN. Now let's learn about the stacking configuration as service switches. Stacking is typically used in the following three scenarios: stacking chassis switches, stacking case-shaped switches using stack cards, stacking case-shaped switches using service ports. Chassis switch stacking. Let's first learn more about the basics of chassis switch stacking. Two chassis switch models support stacking: S7706 and S7712. A stack system can contain switches of the same model or different models. Note that a stack system can have only 2 chase switches, and the 2 switches must run the identical software version. Each switch must be equipped with a pair of SRUs of the same type, but the types of SRUs between the 2 switches can differ. The 2 switches are connected with QSFP high-speed stack cables. These cables can be connected or removed while the power is still on. The stack cables are connected to the VSTSA stack cards on the SRUs. The stack cables must be connected into the correct order. After connecting the stack cables, log into 2 member switches in turn to configure stacking. First, configure stack ID for each switch. The 2 switches must have different stack IDs, which means the stack ID is unique. Then, enable stacking on each switch. Finally, restart the switches for stacking to take effect. After you completed these operations, the stack system is set up. You can log into the stack system through the management port or console port of the master switch to manage and configure the stack system. You can use either of the following methods to view information about the stack system. Method 1. Use the display CSS status all command to view the master or backup status and the stack ID of each member switch. Method 2. Observe the indicators on the VSTSA card of a switch to track the master or backup status and the stack ID of the switch. If the master indicator is static green, the switch is the master switch. If the indicator is off, the switch is the backup switch. If the number 1 stack ID indicator is static green, the stack ID of the switch is 1. If the number 2 stack ID indicator is static green, the stack ID of the switch is 2. After a stack system is set up, each interface on a switch is identified by the stack ID, slot ID, subcard ID, and interface ID. Case-shaped switches can form a stack system using stack cards or service ports. We will begin with stacking using stack cards. 2 series of case-shaped switches support stacking using stack cards, S5700EI and S5700SI. A stack system can only have member switches of the same series. EI switches cannot form a stack system with SI switches. A maximum of 9 case-shaped switches can set up a stack system using stack cards. All the member switches must be running the identical software version. The switches are connected with PCIe stack cables. These cables can plug in or remove while the power is still on. The stack cables are connected to the ETPC interface on rear subcards of the case-shaped switches. The member switches can be connected in a ring topology or train topology. Stacking is enabled on the switches by default, so the switches can automatically set up a stack system once they are connected with the stack cables and power on. This plug-and-play feature reduces technician workload. After a stack system is set up, you can log into the stack system through the management port or console port of any switch to manage and configure the stack system. You can use either of the following methods to view information about the stack system. Method 1. Use the display stack command. Method 2. Observe the indicators on the front panel. Press the mode button on the switch repeatedly until the mode indicator is static red. At this time, the switch is in stack mode. Observe the indicators of service ports 1 through 9. If all these indicators are blinking green, the switch is the master switch and its stack ID is 0. If all these indicators are static green, the switch is a non-master switch and its stack ID is 0. If one of the indicators is blinking green, the switch is the master switch, and its stack ID is the same as the ID of that interface. If one of the indicators is static green, the switch is non-master switch, and its stack ID is the same as the ID of the interface. After the stack system is set up, each interface on a switch is identified by its stack ID, subcard ID, and interface number. The second method to set up a stack system with case-shaped switches is to use their service ports. 3 series of case-shaped switches support stacking using service ports S5700Li, S5710EI, and S6700EI. A stack system can only have member switches of the same series. For example, S5710EI switches cannot form a stack system with S5700Li switches. A maximum of 9 case-shaped switches can set up a stack system using service ports. All the member switches must be running the identical software version. The switches are connected with SFP plus stack cables. These cables can plug in or remove while the power is still on. The stack cables are connected to service ports of the case-shaped switches. Specifically, the S700Li series can use the last 2 service ports. The S5710EI series can use the last 4 service ports, and the S6700EI series can use a maximum of 8 service ports of any positions. To use a service port for stacking, run a stack port interface command to configure the interface as a physical stack interface, and run the port member group interface command to add the interface to a logical stack interface. Each switch has 2 logical stack interfaces. Service ports in logical stack interface 1 on switch must be connected to service ports in logical stack interface 2 on a neighboring switch. The member switches can be connected in a ring topology or chain topology. After the stack system is set up, you can log into the stack system through the management port or console port of any switch to manage and configure the stack system. First, you can use the display stack command to check information about the stack system. Second, on the S6700EI series, you can check the stack system information by observing indicators. The method is the same as that used in a stack system formed using stack cards. On S5700Li and 5710EI switches, check the indicators in the following way. If the stack indicator on the switch is blinking green, the switch is the master switch. Then press the mode button repeatedly until the stack indicator is static green. Check the indicators of service ports 1 through 9. If all these indicators are steady or blinking green, the stack ID of the switch is 0. If one of the indicators is steady or blinking green, the stack ID of the switch is the same as the ID of that interface. Lastly, I will tell you how to reduce the impact of a stack split on the network. A stack split occurs when a stack system splits into multiple stack systems because one or more member switches have been removed from the systems or because multiple stack cables are faulty. Once a stack system splits, multiple stack systems may use the same IP and MAC address. These conflicting IP and MAC addresses will lead to network faults. To reduce the negative impact of a stack split, you can enable the dual active detection function on the switches. This function can detect the configuration conflicts after a stack splits. If more than one master switch exists, one of them is elected as the master. The physical interface on the other switches then shut down and stop forwarding service packets. That's all the information sharing we have today. If you want to learn more about our products, please go visit our website, enterprise.huawei.com. Thanks for watching. Thank you.